All right, next up is hotspot analysis. How many of you have run a hotspot analysis before?
Yeah.
It's usually the most popular tool, so I'm going to spend just a little bit more time on it, but I know that we are, still pretty tight on time. So a hotspot analysis is going to identify clusters of high and low values. So it's a local statistic. It's not just going to tell us if we have clustering of high or low values. It's going to tell us where those clusters are. So I would like to talk a little bit about how this works, because I think that some of us might be using the tool without really understanding what it's doing. So let's take a look here at 45 of my favorite random numbers. And let's say
she's not kidding either.
It's pi, actually, if you
which she knows, like, how many digits of pi do you know?
That's irrelevant.
No, you have to tell us now.
Like 500. Okay, so let's say that I take 45 of my favorite random numbers, and I was to pick them up and shake them and drop them. Now, you don't really need to understand any probability theory to just kind of intuitively know, just really kind of feel that it'd be really unlikely that all of those high numbers would just happen to fall together right here, right? It's obvious that that's not random. But it's not always that obvious. So what a hotspot analysis does is it helps us measure the likelihood of that happening. What are the chances that this happened randomly? So let's take this to a map. And first, let's get clear on a couple of terms. So each of these polygons, we'll call those features, okay? And around each feature, there's a set of features. Each feature has to have a value. So again, we're measuring clusters in high values and low values. So each feature has to have a value. And we also need variance between those values, right? Because we can't have clusters of values if all of the values are the same. So each feature has a value, and we have variance between the values. The next term is neighborhood. So around each feature, and including the feature itself, we have a set of features, and we'll call that the neighborhood. And then all of the features, including the neighborhood, we will call that the study area. Okay, so what a hotspot analysis is asking is this neighborhood that was derived based on the original feature, is that statistically significantly different from the study area? So if that neighborhood is significantly higher than the study area, then that feature that the neighborhood was based off of will be marked as a hotspot. And we have 3 degrees of confidence for hotspots. You can be 90, 95, or 99% confident that that neighborhood is a cluster of high values, meaning that that feature belongs to a cluster. We can also be 90, 95, or 99% confident that a feature is a cold spot or belongs to a cluster of low values. Or if that neighborhood is not significantly different from the rest of the study area, so in other words, it's kind of random, then we'll mark that as not significant. So the tool goes feature to feature and asks, okay, what's your neighborhood? Is your neighborhood different from the study area? Yes? Okay, you're a hotspot. Next feature. What's your neighborhood? Is your neighborhood different from the study area? Yes? Okay, you're a hotspot too. And then we end up going through all the features and we have a hotspot map. So let's run a hotspot analysis.
Yeah. Okay. So I'm going to show you 2 examples of hotspot analysis. One of them is looking at obesity rates in Los Angeles County. This was my the data from my thesis, so I hate it with a passion. But I'm going to show it to you anyway. So we're going to use optimized hotspot analysis, which is a tool that uses under the hood hotspot analysis and is optimized to make it just really easy to run. And we're going to talk in a ton of depth about, we're going to go into even more depth than Flora just did about hotspot analysis and the decisions that you need to make, and what optimized hotspot analysis is really doing under the hood in the session this afternoon. today, you're just going to, right now, you're just going to have to take my word for it that it's awesome and is doing a really good hotspot analysis. So we're going to run the analysis, and it is going to create those, that map for us. And we can, oh, I ran it on the wrong variable. Like that, I know what the hotspot map of this data looks like.
Results window.
Yes. Yay, results window. Okay, %5b. That is the actual variable that has to do with childhood obesity. So this is the percentage of fifth graders in each of these school zones that were overweight or obese. In some of those places, it's over 50%. And so these are the areas, and we can see based on the colors, the places that are where we have more confidence, the places where we have less confidence. And we actually built optimized hotspot analysis with ArcGIS Online in mind, because we really wanted to get hotspot analysis into the hands of a lot of people and into the hands of people. So how many people have run hotspot, the Getis or GI Star statistic hotspot tool and accepted all the defaults? Oh, please. Fine. You don't have to raise your hand, but you know. I know, it's true. So that's why we built optimized hotspot analysis. The thing about the one we build tools is once we build a tool, it has to, essentially, we have to make sure that a model you create with one of our tools works forever, essentially. That's our goal. And we can't just go willy-nilly changing what the output will be. So the defaults are what they are, and what we've done is for optimized hotspot analysis, we've basically created a new set of defaults so that the defaults are really based on us interrogating your data, evaluating the data, and making decisions based on that data. And so this is an example of using that. This is graffiti incidents in New York City, and if we go to perform analysis and we go to analyze patterns, we can find hotspots. If we have no analysis field, we have options to either provide our own polygon. So here we could use police precincts, for instance, or beats. We could also use a bounding polygon that would say where these incidents could have happened. Oh, I did the other way around. But you could provide either of those. Of course, you could provide an analysis field. But in this case, I just let it create the grid for me, and we can see the result of that analysis. And if I click on one of these locations, I can see like the lighter pink one is a hotspot where we have 90% confidence. So now you can do this kind of analysis right inside of ArcGIS Online and really get this analysis also into the hands of more people that won't know the ins and outs of hotspot analysis but can still do a valid analysis.
All right, last in this tool set is cluster and outlier analysis. So cluster and outlier is similar to hotspot analysis in that it finds clusters of high values and clusters of low values, but it also identifies outliers. So let's take a look at how that works. So again, we're separating the feature in the neighborhood from the study area. But now instead of just looking at whether the neighborhood is different from the study area, we're asking, is the feature different from all other features? And is the neighborhood different from all other neighborhoods? And so we have 4 different answers. So if the feature is significantly higher than all other features and the neighborhood is significantly higher than all other neighborhoods, then we have a high cluster. If the opposite is true, the feature is lower and the neighborhood is lower, we have a low cluster. But we can also have a situation where the feature is significantly higher than all other features, but the neighborhood is significantly lower than all other features. In that case, the feature is going to be a high-low outlier. And the inverse, if the feature is lower than all other features and the neighborhood is higher than all other features, then we're going to have a low-high outlier. So a cluster outlier map might look something like this. Where the lighter pink are the high highs, and the lighter blue the low lows, the bright reds the high lows, and the dark blues the low highs. So if I graph the results of this cluster outlier analysis, so here I'm looking at the values versus the z-scores. And we can see here that if the z-scores are low, then we have outliers, and when the z-scores are significantly high, we have clusters. And I can draw this on the map here. So again, the high highs, the low lows, high lows, and low highs. So every of these values is falling somewhere in the quadrant, but you have to be significantly high or significantly low enough. So you'll notice that in the middle here, we have the gray features that were not different enough to be marked as statistically significant. So let's see that in action.
All right, so we're going to use that same dreaded Los Angeles data to do a cluster outlier analysis. So one of the things that we sometimes use optimized hotspot analysis for, one of the things that we create in the messages window, we do a bunch of evaluation, and we'll talk about that this afternoon, but we evaluate what's the optimal distance to use for our hotspot analysis. What's the optimal distance to use for our neighborhood? And this is when this is when you don't have one in mind, one that makes sense for the question that you're asking, and you're just trying to get the tool to help you start to explore what might be an ideal one. But we'll talk about that more later. But we're going to use that distance when we run cluster outlier analysis. So I'm going to run the analysis using that same data. I'm going to use the right variable this time. We're going to use a distance band. This is where we define what it means to be neighbors, how we define that neighborhood. We run that analysis, and it's going to return to us this report, so this map. So what we see here, we see a similar pattern to what the hotspot analysis showed us, but what we can see is that within that hotspot, there are actually these clusters where we have low values that are surrounded by high values, and those can be incredibly important, especially if you think about something like obesity. How did these areas manage to have such low rates of obesity surrounded by places that are, in theory, quite similar to them? They are close by. What are the things that they're doing right that we could try to mimic in other places, for instance? Or we can see the high-low clusters. What are the things that they're doing wrong? How are they failing when others around them are doing so well? And so those outliers can really drive a lot of new questions and can help us, especially when we move into exploring relationships, they can help us get into other if we know, okay, well, this one's doing well and these aren't, maybe I'm missing a variable, maybe I haven't taken something into consideration, and those can help us find some of those variables that might be really critical.